All right, here we go. We're moving on to lesson 8.4. We are talking about the slope-intercept form of a linear equation. So now this is getting really wordy. You will need to know this as the slope-intercept form. And guess what? When I give you this, what you're going to see is a slope and an intercept. So the slope-intercept form will not be hard to remember. Our essential question is, can you use the slope-intercept form of a linear equation? So here we go. The slope-intercept form is y equals mx plus b. Notice that the m, which we talked about last lesson, is the slope. And the lowercase b, in this case, is the y-intercept. So remember, the y-intercept is when x is 0. And it is where it touches the y-axis. So the first thing we're going to do is we're going to observe the following graphs. If I have to graph y equals 2x, I'm going to graph that in orange. It doesn't have a b, so I'm going to put it right at the origin, is what we call that, 0, 0. And because it has a slope of 2, we know this 2 is over 1, so I'm going to rise 2 and run 1, rise 2 and run 1. So this is what the graph looks like of y equals 2x. I'm going to go ahead and highlight that for you. Now if I graph the other one, y equals 2x plus 4, notice we're starting on the 4 because this is my b. Remember, the b is the y-intercept where it touches the y-axis. But this one, when I rise over run, notice it is 2 over 1, so it has the exact same slope. I'm going to rise 2 and run 1, rise 2 and run 1. And notice this one, they are parallel because they have the same slope. So here's a little observation. They cross the y-axis at different points. We have 0 and 4. I guess I just kind of X'd that out. I should show that again. 0 and 4. There we go. 0 for y equals 2x and 4 for y equals 2x plus 4, which makes sense because we talked about that when x equals 0, that is where the y-intercept is. So some of these questions are pretty easy. They just say find the slope and the y-intercept. So example 1 is giving us this question in y equals mx plus b. They want us to find the slope and find the y-intercept. Remember, the slope is always the number before x because this is y equals m. So my slope is -2. Well, this is y equals mx plus b. My b is a positive 1/2, so you can either write that just as 1/2, or you could show it as a point when x equals 0, y equals 1/2. My next question is asking me to graph using the slope and the y-intercept. So again, I need to know that y equals mx plus b. We're going to start at -3. So if this is my origin right here, I'm going to start at -3. And we're always going to start at the b, or the y-intercept. From there, I'm going to graph my slope up to over 1, up to over 1. And my graph is going to look like this. Now notice we put arrows and we draw. If you want to use a ruler or a straight edge or a side of paper, that's fine as well. So I just graphed y equals 2x minus 3. So now we're doing the same graphing. In this case, they give us y equals mx plus b. My m is 2 over 3. My b is -1. So I'm going to graph at -1, put a dot. My slope tells me to rise 2 and run 3. Rise 2 and run 3. So my line is going to be this purple positive line. Now we have a little problem with this one. This one is not solved for y. So the first thing I'm going to do is subtract x to start my solving for y. And I get 2y equals negative x plus 6. All right, when I divide everything through by 2, I get y equals negative 1/2 x plus 3. So y equals mx plus b, we're going to start on the b. At a positive 3, we're going to put a dot. From here, my slope tells me negative 1, so we're going to go down 1 and over 2, down 1 and over 2, down 1 and over 2. So notice this negative line of y equals negative 1/2 x plus 3. And that is the graph of x plus 2y equals 6. We just solved for y to get there. All right, back to our Hoy and our Vux. Notice the first one on the left, example 4, we are given a Vux. So x equals negative 2. We're not just going to stop at negative 2. Remember, Vux means we are going to graph a vertical line. And a lot of us forget that, so don't forget to graph that vertical line. The next one, we do have a Hoy. Don't just stop at positive 3. We're going to go ahead and draw a horizontal line, because that's what the H stands for, horizontal line. Slope is 0 on this one, and it goes through the y-axis. All right, just some things that we're going to get into. Different lines with the same slope are parallel. So if lines have the same slope, they are parallel. And we just saw that in example 1 if you want to go back and look. Parallel lines that are not vertical have the same slope. So kind of the same thing. And we'll just go back and look at those. Remember, we graphed it right here. Those are parallel lines. Excuse my drawing if they're not perfect. And because they had the exact slope of 2/1. So in example 5, if I had to prove that these lines are parallel, how would I prove them? I would probably just solve for y for each of these. So I have negative y equals negative 2x. I'm going to divide everything through by negative 1. I get y equals 2x. And if I solve this one for y, I get negative y equals negative 2x plus 4. And when I change all the signs, y equals 2x minus 4. So notice that here, my slope is 2. And here, my slope is 2. And that would be how I prove and show that these two lines are parallel.